Brace yourself for the third part of our PREEvision systems engineering tutorial. We'll move on to the logical viewpoint right away. I will demonstrate how to model a system from a logical viewpoint. In the design of a logical system, its individual functions are integrated into logical blocks that can be implemented as hardware or software components. I will therefore also show you how to link the logical design with the functional design, with the software and hardware design, and with requirements and test specifications. Let's begin. To design our robot vacuum cleaner system from a logical viewpoint, we open the respective logical function package in the System Architecture category in the Systems Engineering Explorer. To display its logical architecture, we double-click on the corresponding logical architecture system diagram. The logical architecture of our example system consists of 3 building blocks that correspond to the smartphone app, the robot vacuum cleaner itself, and the base station. Building blocks communicate with each other by exchanging signals through the sender and receiver ports. We double-click on the robot vacuum cleaner building block to view its details. In turn, the robot vacuum cleaner partial system consists of 3 building blocks. They describe the logical design of the subsystems for control, routing and navigation assistance, and cleaning. Now let's take a closer look at the logical design of the routing and navigation assistance subsystem. It includes 3 blocks representing the logical functions collision avoidance, terrain awareness and warning, and instruments. Besides that, there are 2 sense blocks representing terrain and intruder localization. The collision avoidance function receives terrain data from the terrain awareness and warning system, position and movement data from the robot vacuum cleaner controller, and information about possible intruders from the intruder localization sensor. It also receives optional advisories from the base station partial system. The collision avoidance function provides traffic advisories to the robot vacuum cleaner controller and the instruments function. The instruments function selects the traffic advisory based on the terrain data it receives. Then it provides the traffic advisory along with the status of routing and navigation to the control subsystem. We can specify the detailed functions of logical blocks using activities or state machines. Let's open, for example, the state machine diagram, which describes the states and transitions of the collision avoidance system. To view the connections between the functional and logical viewpoint, we select the topmost logical function package containing the logical view at the robot vacuum cleaner system. Then we open the functional and logical architecture link table. For example, let's expand the contents of the robot vacuum cleaner package in the left column of the logical system architecture table. The right column of the table shows which activity partitions of the robot vacuum cleaner's functional architecture correspond to blocks of the logical architecture. To view the requirements, components, or test specifications of the software or hardware that are linked to the blocks of the logical architecture, we open the corresponding link tables. For example, we open the hardware requirements link table. The logical system architecture table shows which parts of the logical architecture are addressed by hardware requirements. That's it for logical design. In part 4, we will discuss the physical aspects of our system and examine the modeling of its software architecture. See you there. Would you like to check out model-based systems engineering with PREEvision for yourself? Go for it. We offer the example model from our tutorial in a hosted PREEvision environment. There, you can perform the tutorial steps yourself using PREEvision. If you are interested, please visit preevision.com/trial. Thanks for watching.